Hello everyone, welcome to Troopers International. This is Salahuddin Makanda. Today I teach you the laser welding process to simulate in the Ansys. So first of all, the laser welding process is the process in which the two metal parts are joined together with the help of the laser. Consider that there are two blocks having the dimension of 72, is shown in body 72 by 50 by 25 mm. Okay, there are two blocks is connected to each other but not in united but different. So this file is converted into the IGS format. This is draw in the draw in the unigraphics because I am familiar with the unigraphics. So convert it in the export in the IGS format. This is IGS format. Check the desktop. I will give you a number. Laser blocks. Okay, just apply. Okay, IGS is very important because this is boolean, and when we go to the simulation, after all simulation the geometrical error arrival, so IGS format is need to correct. So after IGS, open the Ansys file, take a transient thermal, go to engineering data. We have two material such as structure steel and adding another material like a stainless steel. This both material we give for laser welding. Enter the geometry, import the geometry, browse. From the desktop, the blocks can be opened, and after that update the project. Okay, this is updated project. Go to the model, edit it. Okay, the model is open. This is the two blocks. So first of all, in the geometry, we go to first block, we give structure steel, and the second block we put the stainless steel. So this is first, and go to the mesh. The mesh is like that. This is a simple mesh. If you require the course, fine as per your demand. Okay, so initial insert. So there is, in a laser welding, initially first of all we use the mechanical APDL command. So the external source provided like a moving heat flux is showing that point, moving heat flux. We added a moving heat flux. We teach you how to simulate that. So the first is scoping geometry. The first is a geometry. The geometry is that is do these two planes we have to connect each other. So apply. Okay, the path is required, the path, so select that path, and the mating points, this path we required, so this is apply. Okay, so next we require a start and end point. So go to the this point and press Ctrl and mouse click. This is start and end point. Select apply. Okay, the index is 1, path is S, and of course S. The main thing is the velocity and the time. The product of velocity and time is equal to length of the path. The length of the path is 72 mm. So we are this 10 mm, and the velocity is 0 72 mm. And next, the melting temperature is 800 degrees Celsius. Initial temperature analysis setting for 50 second. We take for 50 second. And next we put a convection because it's cool it itself by after applying the laser welding. Select all, apply, and go to the okay. Okay, there's after that solid. It's required huge time because of lots of processing data is required. And if you go to the if you go to the close meshing, and this time will be expanded. This laser welding is very helpful in a research engineering project. You can analyze how the flow of the laser and what is has region is very helpful. So it is very important for that. So the ACT, moving heat flux, and like that, moving heat flux, moving heat energy, material remove, mean temperature. This is a external sources apply. I will give you the I will give you the my Google Drive locations for your for your download. You can take it that. So see that the process is take a huge time for that. So the overall process is done. The solution is completed. So insert, go to the solution, insert thermal temperature. So after temperature, solid result. Okay, solid result, and insert. So we go to the frame 100 for 10 second. Show that. Like that. The heat flux is flown, and also we take total flux, evaluate all result. Okay, just go. Okay, so this is a type of laser welding with the help of SCT extension. If you required any related Ansys project, please message me and subscribe my channel. Thank you very much.